going to shut it now, and we'll see disappears without Okay, so now I'm going to keep talking and see if, when I keep talking, there shouldn't be sound output. This thing should shut up. La. Okay, so the problem was that when I speak normally, there's pauses, and they're long enough to trigger a gap between. And in that gap, that's when the sound output happens. But if I sing a long note like this and I keep talking or I don't make pauses, then it won't. Well, you get the idea. It's called note release. Okay, well, it's a little hard to see. There shouldn't be sound. So, okay, this is what I think is happening. I have a better idea now. This was from Audacity Debug. Let's save that. Audacity file types. Yep. New. So, I was about to say something. Yeah, so we have... Oh, you know, we have a good drawing for this already. It's called delay buffs. Nope. Scrap. Yeah, this guy. So you see, this is the mic, or the guy talking into the mic, and this is the speaker output. Yeah, and this is the basic idea of what happens. But now I realize when you talk, there's a lot of gaps like this, and they're long enough. We do say minimum gap. If there's a gap of just like one buffer, then we just say, okay, just make that a sound. I think we do that up to 3 buffers. But 3 buffers is actually pretty fast in human time. That's like, if each buffer is about 1/40th of a second, 3 buffers is 3/4 of a second, which is more like 1/10 of a second. And that's still pretty fast. When I make some consonant sound after that, I could see that I've always wanted to say the word diphthong, and that's a great example of when you capture all your energy to make that P. There's a silence that probably lasts, I don't know, potentially around 1/10 of a second. So those kind of things could be triggering these gaps. And that will allow, you know, some other sound to start up here. So if this was the case, where's the eraser? Yeah, so if this is the case and, you know, you get something like that, you get a sound like that. And there's actually a little gap here. Instead of something like this, you might get something like this. Yeah, so it'll be the same audio, but what will happen now is this takes yeah, at this point, this is when we have the onset. At this point, this mic, the mic has precedence because it's in use. So this part gets cancelled out. But then we drop down and we lose the mic input for a little while. So then this guy picks up and he says, okay, I'm going to output a sound. And while we're outputting a sound, we don't let the mic take input. So we get an X here now, which is the opposite of the previous picture. And actually, no, that's right. This is correct. Yeah, and this part is heard. So you get this weird switching back behavior. And this is if our this is not even taking into account the latency of the code with our callbacks. We know our latency is going to be at least the buffer size. It depends where we're calling the function from, but yeah, we have to assume it's at least that and probably more. And that adds an additional layer of complexity. Right now I'm thinking just to simplify it and say if there is mic input if there is output, just don't take input, and that's the only rule. Will that be enough? If there is output happening, no, that's not enough because we don't want the feedback again. So when I'm saying something, if a sound happens midway through my sentence, and we output a sound there through the speaker, it's going to go back in through the mic. And I don't want that kind of thing to happen. This is a voice processing app. I mean, we could just blow the system away too and say user presses, and that's when we mute, and that's really the simplest thing to do. But this is a kind of interesting problem. Yeah, so the other thing that I believe is happening is when we have, let me copy and paste. Oh, I hope there's a copy and paste. I haven't used this tool that much. Oh, there needs to be a copy and paste. Let's see. No. Yeah, no, I do not know if there's a copy and paste. And that would be tragic. Because, I mean, look at this program. You can even draw leaves. Well, I don't know if that's a leaf. But there's even a DNA brush. Pretty much looks like real DNA. But it is, if it's very excited about this program, but if there's not a selection tool, that could be the deal breaker. Oh, that's sad. That is very sad. Okay, so it looks like I won't be able to use this program forever. I hope I'm wrong. But anyway, I'll draw a slightly different picture. So there's also the case where we only have output. So this is speaker output. And yeah, we output in blocks. Some sounds will actually contain silence like that, but the way we deal with output is quite different from input. So say this corresponds to one sound object, and the sound just gets quiet at some point. This isn't an issue, because the mic cutting out part just looks at if there's sound objects in the mixer. It doesn't look at the volume or anything. Yeah, so there's the case where I'm going to draw a line here to separate things. There's the case where I don't know why I used something that looks like the letter P to draw people, but he's completely silent. He's not saying anything. This is the mic, and the mic can take feedback in if we don't handle it right. And what I'm seeing is we're outputting on the speaker here, and right around here we get a small little sound input and taken in. And I think that's because when we release, so at this point we release the sound and we say, okay, it's safe to turn the mic back on now. So that change happens well, it's really tricky to wrap your head around a concrete latency problem because of stuff like this. So you're wondering, is the code being... You know that the code is being executed when it's being executed, because that's a tautology, and I don't know why I said that, but for one thing, there are several threads. One's the update thread and one's the analysis thread. We don't do and the mic part, the mic analysis part happens in the analysis thread, which happens later. And that's the only place we set and unset the mic. But the thing is, once a sound finishes, so once it sent all its buffers to the audio callback, it's definitely not true that the sound is at that instant output, right? Because the OS has to process it and send it to the speaker, and has to follow within the correct order. So what we end up doing here is it's this is almost like relativity. Maybe it is of a different sort, super specialized relativity. No, but I think we're just overcomplicating things. So this is when we send the buffer, and whatever the latency is, might look like this much. There might be this much more sound, like this much amount of time passes and the sound still goes. So the sound actually happens like this, and this is what latency is. And that means it'll go into the mic, and I'm not sure. So this is just the output delay, but when you're coming back into the mic, there could be an additional delay, because yeah, no, it's really hard to say, but yeah, there could be a little bit of extra delay. Anyway, so this is the sound we record. We end up recording this chunk. It goes there. And, well, fortunately for us, we are not doing input to output directly, so we don't have to worry about this kind of thing. The sound going up here and then coming back down here. So this would be the actual feedback latency. But we don't have to deal with that, because this is a one-way thing. We analyze it, and we output it at a time of our choosing. Not instantly. Which is not instantly. So, how can we... this is not behavior that we want, because we would like all the stuff from this sound to not go into the mic. And essentially we need to figure out how much is the audio being delayed.